Hi, for our CSE 6250 Big Data for Health project, we are trying to predict patient mortality in the ICU using the MIMIC-3 dataset. Based on our research, we found out that hospitals in USA are understaffed. Efficient allocation of doctors and nurses in the ICU can lead to lower mortality rates. So we decided to use structured and unstructured ICU data from the MIMIC-3 dataset to build a machine learning model that can predict patient mortality in hospital 30 days after discharge and 365 days after discharge. We tried to follow the work of Gasemi, in which they used structured and unstructured data to predict patient mortality, but also we did certain things differently, which I'll elaborate on. Our objective, as I described earlier, was to predict patient mortality. It was also to measure the effectiveness of unstructured data obtained from clinical notes. A lot of work has been done using structured data, but not a lot has been done that made use of the clinical notes from nurses. We also compared various machine learning models for the same task. Our reference paper from Gasemi used only one model. We tried to use and compare several different ML models. We first did some descriptive analysis of the data set, and as you can see, we had 30,000 alive patients and around 16,000 dead patients, and male and female. Uh, we did descriptive analytics based on ethnicity, and some of the useful statistics that we analyzed were ICU stay length, prescriptions per patient, labs, notes, procedures, and diagnosis. This was our methodology. We first divided the entire window of an admission into three different prediction windows: in hospital, 30 days after discharge, and 365 days after discharge. We had five different feature sets. The first one was the most simple, based on admission baseline features using age, gender, and SAPS2 scores. Then we had derived feature sets that had 30 comorbidity scores in addition to the admission baseline features. And finally, we had the topic model features from unstructured clinical notes. And then we combined the topic model with the previous two feature sets. We compared four different algorithms: decision tree, boosting, SVM, and neural networks. For each of them, we tuned respective hyperparameters. Our machine learning pipeline was to first scale the features for zero mean and one variance, that is the standard scaling. Then we did the randomized hyperparameter search with five-fold cross-validation to find the best parameters for each of the four algorithms, and then divide. We initially divided training and testing set into a 70-30 split, and finally tested the uh, model on the 30% test set to report the AUC scores. These are some of the topics that were generated by the LDA model. As you can see, we have shown three sample topics. If the clinical notes contain words like atrial, premature, beats, ventricular, then it can represent a topic a patient that has a heart condition. Similarly, the third row shows words that can indicate a discussion of end of life care, such as family, today, bedside, comfort. Finally, these were the results we obtained. As you can see, SVM outperformed all the other models in terms of accuracy as well as training time. Neural net did achieve close to the accuracy achieved by SVM, but it took significantly more time for training. And the best feature set, as expected, was a combination of topic, baseline, and EH comorbidities for all three co-prediction windows. And we had highest accuracy for in-hospital, followed by 30-day, and finally the lowest accuracy for 365-day prediction window. And so, yeah, we concluded that unstructured data indeed provides value to increase the accuracy, Linear models such as SVM are not only accurate but are human interpretable, and so we should use them. And mortality prediction is possible using ICU data and machine learning. And that's it. Thank you.